all of you. Welcome to this presentation of Meteosat Third Generation European Geostationary Satellites. This will be a more or less overview presentation because it would be very hard to put everything about Meteosat Third Generation in 1 hour presentation. But I still hope I will get some things closer to you that you maybe didn't hear yet, although I'm pretty sure that most of you already have quite a good knowledge and understanding what the next generation Meteosat satellites will offer. And now that I said hi to you and that you all saw me, I will close my camera just to save the bandwidth. So Meteosat Third Generation. As you know, geostationary satellites, as the Meteosat Third Generation satellites will be, is just one of the 2 types of meteorological satellites. Satellites in geostationary orbit are primarily in charge of monitoring the weather and are vital for nowcast and very short-range forecasts. On the other hand, we have polar orbiting satellites, which are actually ensuring the global coverage of the Earth and are irreplaceable source of data for especially NWP for medium-range weather forecasts. So EUMETSAT currently operates 4 geostationary satellites. These are Meteosat Second Generation, Meteosat 8, which provides the Indian Ocean data coverage. Then there is Meteosat 9, which serves as a backup satellite and gap filler for rapid scanning service of Meteosat 10. And then there is Meteosat 10 that provides currently operational rapid scanning service, and Meteosat 11, which provides operational full disk imagery mission. Besides these 4 geostationary satellites, EUMETSAT operates 6 polar orbiting satellites. 2 of them are METOP satellites, METOP B and METOP C. On this image here, you still have our nice METOP A that has been retired I could say a few days ago or a few weeks ago. It was retired after 15 years of reliable service. So now we have only 2 METOP satellites, METOP B and C. And besides that, EUMETSAT operates Sentinels 3A, 3B, Sentinel 6, and also JSON 3. So this is the current constellation of EUMETSAT satellites in the orbit. In the next 5 years, this EUMETSAT fleet will be upgraded to a new generation with 3 new Meteosat Third Generation geostationary satellites and 2 new EUMETSAT Polar System Second Generation satellites. Today, I will talk about the next generation of geostationary satellites. These are these 3 nice MTG satellites, which I will just say something about. So the concept and the construction of the next generation geostationary satellites will be very different from the current MSG. New satellites will not be spin stabilized. They will be 3-axis stabilized, and the spacecraft will be much bigger than the current MSG satellites. So they will be larger in size, and they will be differently placed in the orbit. The concept, so the 2 satellites 2 of the 3 satellites will be imaging satellites. They will provide imagery mission. They will be called MTG I1 and MTG I2. They will provide full disk imagery every 10 minutes in 16 bands, the first of them, and the second one will provide fast imagery of Europe every 2.5 minutes. They will also carry on board lightning imager, and the start of operations of the first MTG satellite, MTG I1, we expect to be in 2023. Then the second satellite in the constellation will be sounding satellite. That will be one satellite of the 3, and it will provide hyperspectral infrared sounding mission. So in order to give you let's say a vivid look. Oh, sorry, video did not start. I hope you see it. I'm not sure that you hear it.
No, we can't hear it.
No, you don't see it. So, okay. So the Meteosat Third Generation constellation will consist of 3 satellites. The first satellite will host the prime service, which is the imaging service. This satellite will have on board the flexible combined imager, the lightning imager, and the data collection and the search and rescue support platform. The flexible combined imager will take images of the Earth every 10 minutes in 16 different spectral channels. This gives us information about clouds, their properties, and the information about the land and water surfaces. The lightning imager consists of 4 cameras that give the information about the lightning over the full disk day and night. So this is the lightning imager. The Meteosat Third Generation imaging mission will provide information for nowcasting and forecasting, and it will be especially valuable in nowcasting severe weather. The second of the satellites, MTG-S, will provide the sounding service, taking the vertical information about the atmosphere. There are 2 instruments on the spacecraft, the infrared sounder and the ultraviolet visible and near-infrared sounder. The infrared sounder provides the information on the temperature and humidity in the atmosphere. We get the information over the full Earth disk, and the information over Europe is provided every 30 minutes. The Copernicus mission provides the information about the composition of the atmosphere over Europe. This atmospheric composition information will be a new information for weather services and other services in Europe. The third satellite in the constellation, this will be again MTG-I. MTG-I2 will provide the rapid scanning service and will also host a backup for the lightning imager instrument from the MTG-I1. Flexible combined imager on MTG-I2 satellite will provide images of Europe every 2.5 minutes, which will be very important in monitoring very rapidly developing storms. All the information provided by MTG satellites will be made available across Europe and the world and will be used for weather monitoring and forecasting, but also for atmospheric composition monitoring. Oops. Sorry. Okay, good. I managed. Sorry about this. So I'm sorry you couldn't hear the sound, so I tried to interpret the movie so that you have a slight visual and sound feeling what this will look like. Let us move on. So the first of the MTG satellites, MTG-I1, is scheduled for launch end of 2022, and it is expected to start the services 1 year after launch. So by the end of 2023, we expect to have MTG-I1 in service. Then the MTG-S1 should be launched in early 2024, and again together with MTG-I1 by the end of 2025, we expect to reach the partial operational capability with both imager and sounder service in the orbit. And then sometime in 2025, the second MTG-I satellites and second MTG imager satellites will be launched, and then probably by 2026 we expect full operational capability, where we will also have the rapid scanning service in place and the backup for the lightning imager from the first satellite. So this is the current plan. Of course, plans can go wrong, but we sincerely hope that they will not. So what we will have with this within this initial operational capability, you can see here that the Meteosat 10, before the full operational capability, will still serve as the backup satellite for MTG-I. And then once the MTG-I2 is launched, then we can expect it to take over the backup function. So MTG Lightning Imager will not have backup, as well as sounding infrared sounder will have no backup, since it is completely new instruments that will be flying with the next generation of Meteosat data. So this is shortly about the constellation and the instruments, and now let's move on to see how this generation will operate. First, the imaging service. The MTG, the flexible combined imager on MTG-I1 will support the full disk scanning service. So it will sample all channels of the full disk every 10 minutes, as we already heard. It will be 16 channels in the new generation of the imager. On the other hand, the rapid scanning service, flexible combined imager on MTG-I2, will sample all channels in the top quarter of the full disk every 2.5 minutes. So they will provide very rapid scanning of the atmosphere every 2.5 minutes. Now, from the spectral resolution point of view, currently we have, with current Severi imager, we have 12 channels, 4 in the solar and 8 in the thermal part of spectrum. Spatial resolution of almost all the channels is 3 km in sub-satellite point, except the high resolution visible, which has the resolution of 1 km in sub-satellite point. The next generation imager, flexible combined imager, will have 16 channels. 8 of them will be in the solar and 8 in the thermal part of spectrum. So the largest change actually in spectral resolution will be in solar channels, where besides 0.6 and 0.8 and 1.6 that we have now with Severi, we will have 2 new channels at 0.4 and 0.5, which together with 0.6 micron channel will enable the true color image of the Earth, something like what we would see with our own eyes or similar. So they will support the true color imaging. Then we will have new channels in near infrared part of spectrum, 0.9, 1.3, and also 2.2. All these solar channels will have the resolution of 1 km per pixel in sub-satellite point, so the same as we now have with high-resolution visible images. And 2 of these channels, 0.6 and 2.2, will have the resolution of 500 meters. This will, I'm sure, prove to be very, very important, especially in convective cloud analysis and cloud phase analysis with such a great resolution. The thermal channels, the 8 thermal channels, will remain pretty much the same, or at least similar. The infrared 3.8 will be a bit different. Currently we have 3.9 micron channel, and the infrared 10.5 will be a bit different than current 10.8, but this will still be the real thermal channel as it is now. The difference will be that these 2 channels, 3.8 and 10.5, will have 1 km resolution, so the same as we now have with high resolution visible. And the rest of the infrared, the rest of the thermal channels will have 2 km resolution. So all of the channels will have better resolution, and especially the solar channels 0.6 and 2.2 with 500 meters, and 3.8 and 10.5 with 1 kilometer will be great novelty with the new generation of the imager. So what will it look like? I do hope that you can see the movement on the screen, because sometimes the WebEx does not transmit the speed of the images as they look, for example, on my screen. But you can probably imagine what is the difference between 15-minute scans and the 10-minute scans as we will have with nominal operation on the FCI, and also the difference between 5-minute rapid scans and 2.5-minute rapid scans as we will have with the new MTG I2. You can see that especially for the convective clouds development, this very rapid scanning is really important because the changes on the cloud tops are happening obviously with the distances less than 5 minutes as we could monitor them now. As we talk about the spatial resolution, you can see the difference between the future 500 meter or 1 kilometer spatial resolution and the one that we have with current severe images. So the analysis of the cloud tops will be much more precise and detailed than it is now with the current generation of the imager. A good example is also the analysis or the detection of fog areas, especially very narrow valley fog, where we have where in current generation imagers you can barely see these pixels because this is very small and narrow area. Whereas with the new imager, especially with a very high resolution, you can see that you can monitor greatly also the valley fog and the very small resolution areas. Here as well, this is a night microphysical RGB, which also shows you the difference between the current severe capabilities in detection of night fog and the ones that we will have with MTG. This is a proxy taken from Aquamodis imager instrument with the resolution of 1 kilometer, so the resolution that we will have available with the MTG. So you can see that the difference is, however, really good, big, and it will be useful. What probably we can also hope for, and we can be happy for, is the better ability of fire detection. So both 3.8 and 10.5 micron images should have a 1 kilometer resolution. So the products for fire detection will be much more precise. As you can see here in this example, on the left-hand side, the fire detection by Severi and the future one mimicked by the MODIS data. So this better resolution in 3.8 and 10.5 micron channels will definitely bring a lot to the fire detection capability. What we are really looking forward to is the new RGBs that will be possible with all the new channels of FCI. So the more channels will enable at least this, as you see in the screen, the 4 new RGBs. But I'm sure that in the time that is ahead of us and that we are still investigating the capabilities of the new channels, I'm sure that some of the new RGBs will pop up as well. So the True Color Rgb is one of the new RGBs that will be possible with the new channels Cloud Phase Rgb, Cloud Type Rgb, and also Fire Temperature Rgb with the 3.8 micron channel and new 2.3 micron channel. The True Color Rgb, composed of 0.6, 0.5, and 0.4, as I already said in the beginning, will enable better view of, for example, haze and smog, volcanic ash and smoke, and also better view of the vegetation and the ocean color. So the algae bloom will be visible with this RGB. Currently, we have this ability with the imagers with the instruments on the polar orbiting satellites, but of course with the temporal resolution, which is far worse than it will be with the new MTG. So we are looking forward at being able to monitor all these phenomena in a 10-minute interval, as we now don't have it. The next, so you can see here in this example, an example of wall of pollution crossing the Sea of Japan. This is the true color RGB made from the channels on Himawari 8 imager satellite AHI, and this is mimicking great, so in details what it will look like with MTG as well. So this is one type of the data that we currently use as proxy for MTG, since Himawari has some similar channels as that will be available from MTG. The next RGB is the cloud phase RGB, which was mentioned. Cloud phase RGB will offer much better distinction of ice and water clouds, and also cloud particle sizes in both cloud phases, so in both water and ice clouds. This RGB is composed of 1.6, 2.3 or 2.25 as it will be, and 0.6 micron channels. As you can see, it uses both 1.6 and 2.3 micron channels, which are both sensitive to particle size and phase. So you can see a very good distinction between ice clouds, which are in these bluish colors, and the water clouds, which are in yellow to pink colors. So you can see good distinction between different types of clouds, but also particle sizes is different. So you have these here lighter and darker shades, which depend on the particle size of the clouds. What is also seen in this cloud phase RGB very well is snow and ice on ground, and also vegetation is very well depicted. You see here a few more examples of different cloud types here with yellow, pinkish, and bluish colors. Here different particle sizes in this storm cloud top, and also snow on the Alps in dark blue shades, typical for snow in this RGB. An example, nice example that we have of using cloud phase RGB, and this one was made by Maria Puca from VIRS data. So this VIRS cloud phase RGB shows us actually how we will be able to distinguish also the type of snow on the ground. So not only will we be able to see that there is snow on the ground, but we will be able to see also whether the snow is fine or coarse. For example, here you can see the difference between these dark blue areas, which show you smaller reflection in both 2.25 and 1.6, and here in this area, which shows you larger reflectivity in 1.6 and 2.25, telling you that this snow here is coarser, so it has larger particles. It has it's probably partly melted or has larger grain size, and this one lighter is smaller grain size, fresher snow, like a pulver snow. So this is something that will be available with the MTG imager as well. The next RGB, which is of interest and will be available, is Cloud Type Rgb. This one includes 1.3 micron channel, and besides cloud phase, it also reveals the cloud optical depth, and the vegetation is also seen in this RGB. And here are the few examples, so you can see how the clouds appear in the Cloud Type Rgb, so you can clearly distinguish high ice clouds from water clouds, higher from lower clouds. And I especially like this example made by Ivan in the middle of the screen, where you can see the high thin ice clouds making shadows over the low clouds below. So the contrails making shadows on the low clouds below. And here, which is very interesting, is the snow over the Alps, which is green, whereas the snow in the lower areas appears in green colors. So this is the difference in the cloud type RGB. A very important RGB will also be fire temperature RGB. These are the examples from GOES and NOAA satellite VIRS and ABI fire temperature RGBs, here the one as well as here, which shows what the fire detection will look like during daytime in the MTG data. So the fire detection will definitely show great improvement with the MTG data. And another example which shows the comparison between current ability with 3.9 micron channel and the RGB composite of the 3.9, 2.3, and 1.6 micron channel, where you can see the fires in this red as red-yellow dots here. So the fire detection is definitely an area where we will greatly benefit from the higher resolution and the higher spectral resolution of the new imager. So for all of you who are interested in maybe investigating what the new RGBs will look like, you can look already in the EUMETSAT web pages, where there are quick guides for all the new RGBs that I have now mentioned, and also for some of the new channels like 1.3 and 2.25. So you can look at the properties of these different channels and the RGBs that will be available with the next generation of Meteosat geostationary data. So now we talked about the imager. Let's move on to the lightning imager that will also be an instrument on board of the MTG-I satellite, so the first one to be launched. As you know, lightning can be considered as a precursor of severe weather, so it can even provide lead time for warnings of severe weather. So the lightning imaging from space will definitely bring some novelty to our concept of the weather nowcast and forecast. The difference is the current mostly ground-based lightning location systems. They are mainly sensitive to cloud to ground lightning. There are, of course, also systems that can detect intra-cloud lightning, but mainly sensitive to cloud to ground lightning. On the other hand, the lightning imager will monitor total lightning, so it will monitor cloud to ground lightning, but also intra-cloud lightning. And this total lightning is actually the parameter that we are interested in. If we look at the statistical overview, we can see that in general, over the year, we have high flash density over South and Southeast Europe and Sub-Saharan Africa. So the highest, of course, over the intertropical convergence zone, the continental part over Africa, but we have quite high flash density over South and Southeast Europe, and this is something that lightning imager will help us monitor in the future. So as I said, it will measure total lightning, unlike the ground-based networks that mostly measure cloud to ground lightning. The lightning imager is actually consisting of 4 cameras, as you saw in the movie beginning. It will enable continuous monitoring of lightning flashes over the entire Earth disk with 4.5 kilometers spatial resolution in sub-satellite point. And on the right-hand side, you can see what a satellite instrument looks like. This is a sketch. This is not a photo, but this is something that it should mimic what it will look like. It consists of 4 cameras. So the projection of the field of view will look like this. On the left-hand side, you can see what these 4 cameras will be viewing from the space. And in the end, you will get an image of lightning flashes or groups similar to or actually covering the areas shown here on the right-hand side. So covering all of the continental Africa and Europe and large part of the Atlantic Ocean as well. The products derived from the instrument data will be arranged around these following 3 categories. So there will be events measured. So this is what the instrument measures, pixels that triggered that were triggered in the detector grid. Then there are groups, neighboring events that are grouped in the same during the same integration period during 1 millisecond, which actually represent lightning strokes. And then we have flashes, which are collection of groups in temporal and spatial vicinity representing a lightning flash. So these are the 3, let's say, products that will be available from the lightning imager instrument. Currently, a similar instrument is flying on board NOAA geostationary satellites, goes east and west. It is called Geostationary Lightning Mapper, GLM. And also there is a lightning mapper on board the Chinese FY4 satellite series. So we actually already have precursor instruments, and we can see what the product will look like. Like, for example, in this example of Rgb and lightning data overlaid, this is an example from the GOES East satellite, and you can see what it could look like when using the MTG, Rgb, and lightning data overlay. This is similar to this one here. This example shows also one GLM GOES 16 example, where you can see many events combined into groups that form one flash. So you can see here what it can also look like in the visualization. This is also example from the GOES satellite. And another example here, which shows here flashes in the last 10 minutes in blue with circles indicating flash area coverage, and in the colors red, yellow to red, are flash counts in the last 2 hours. So this is something that can also mimic what it could look like with our lightning imager data. Monitoring these changes in lightning flash activity will enable warnings of severe weather, like this example of a severe convective storm. We can see here how the lightning activity changes in the lightning imager data compared to radar data, and also the view of the top of the cloud from the this is the sandwich composite or sandwich image, combining the visible data underneath and the infrared data colored on top of it. So this were just a few examples what the combination of the data, infrared data, or other RGBs with lightning imager could be. Another product that I'm personally also looking for, because there was many investigations and many studies that showed that lightning jump can be considered as a precursor of the severe weather at the ground, especially connected to large hail events and strong wind gusts. So I'm looking forward to having a new nowcasting SAF rapid developing thunderstorm lightning jump product that will include also lightning imager data and enable us to see the changes in the lightning rate during time, and by this also the ability to predict or to see the jumps of the lightning activity in time and to predict the possible severe storm severe storms or severe severe weather at the ground, especially large hail. This is something that could really help in nowcasting. So Lightning Jump and the new Lightning Jump product from Nowcasting SAF, which will use the Lightning Imager data. So Lightning Imager together with FCI, these are the two instruments that will fly on board the MTG I-1. MTG-S satellite will have on board the infrared sounder, and the infrared sounder is a hyperspectral sounding instrument which will have around 850 channels, and by this it will enable temperature and humidity profiling of the atmosphere with actually unprecedented spatial and temporal resolution. Besides humidity profiling, as you can see here in the spectrum, it will also have channels that will enable monitoring of the atmospheric composition, so the constituents of the atmosphere. And you see here on the left-hand side in the corner, nicely developing the cube of the data. This is mimicked by IASI level 2 profiles, but this is something that we will have also with the IRS sounder, only with much better spatial and temporal resolution. The spatial resolution of the instrument will be 4 kilometers in the sub-satellite point, and over Europe we will have repeat cycle of 30 minutes. So actually the Earth disk will be covered, the scanning pattern will cover the Earth disk in 4 local area coverage or LAC zones. It will take instrument 15 minutes to scan each of these zones. And the scanning will be done so that the LAC 4, so LAC that contains Europe, will be scanned every 30 minutes, and in between the other LACs will alternatively be scanned one by the other. So we will have image of, we will have infrared sounder data profiles available over Europe every 30 minutes. What we could use it for, first of all, of course, if you have profiles of temperature and humidity, what comes to each forecaster's mind, you can get something similar to radio sounding in many points, and you can calculate stability parameters, you can calculate CAPE, or you can see what the low-level humidity is, what is the temperature profile, where you have your inversions, where you have your instability. So this is something that will be enabled with IRS, as it is mimicked here by IASI profiles. You see here in these dots the values of CAPE calculated from IASI profiles and compared to ECMWF model, which is below. And in these areas where IASI profile actually shows higher instability than the forecasted instability is, you can see that you have widespread convective development very soon after the measurement by IASI has been taken. We expect to have this with IRS every 30 minutes, so such measurements, and you can imagine how big benefit it will bring to assessing pre-convective environment and following the development of convection. So this will, besides this direct, let's say, nowcasting, of course, the profiles will provide very valuable data, especially for assimilation in the NWP, including the rapid update cycle models, because the data will be available every 30 minutes. The assimilation in rapid update cycle models will as well be possible. Besides the profiles of temperature and humidity, data from IRS will enable calculation of the 3D wind profiles. Currently, this is done based on IASI data. The products are still being developed. And all this mentioned data, so the FCI, the Lightning Imager, and the IRS from the MTG satellite will give us the view of the atmosphere with temperature and humidity profile, winds, and the view of the structures and the processes on the storm tops, together with lightning observations on top of everything. So a 4D weather cube, this is something that we are looking forward somewhere in 2026 when all of this will be in operations with 2.5-minute rapid scanning. This is something that we will have available. But also before that, of course, just after the launch of the sounder satellites, we will already have the ability of deriving such a 4D weather cube. So we expect to have a great contribution to nowcast and forecast, especially of the high impact weather, so the convective storms and convective clouds and storms. But besides that, of course, an immense contribution to NWP and also to the even more important rapid update cycle models. So to look at the timeline of the product dissemination a little bit, we can see that our full disk scanning service in 16 channels at normal resolution and rapid scanning service will be available both from EUMETSAT satellite and terrestrial in near real time. Also from EUMETSAT terrestrial, additionally, we will have full disk scanning service in high resolution for 4 imager channels at high resolution available as well. Level 1 data from Lightning Imager will not be available, only level 2 data, whereas from IRS, principal component scores will be available as level 1 data, both from EUMETSAT Europe and EUMETSAT terrestrial. All of these, what will be available in the EUMETSAT services will be disseminated also will be available also in the archive. In addition to that, in the archive from the IRS, besides the principal components, also full spectral channels will be available. So this is something that what you can see, what the dissemination will look like. Level 2 products, there will be a great range of level 2 products available, and they will include products from FCI like atmospheric motion vectors or fire detection or global instability indices, etc. So many products as level 2 products from FCI. From Lightning Imager, all the products that will be available will be level 2 products, so the accumulated flash area and flash radiance, accumulated flashes and groups. So this is something that we mentioned before, what it looks like. So this will be this level 2 products that you will have available. And then from IRS, there will be different profiles of temperature, humidity, ozone, instability indices, and then some other products. And also, I didn't mention until now, but one of the instruments that will be on board of the satellites will be also UVN, so ultraviolet sounder, and these are the products that will be available, so mostly atmospheric composition products from the UVN. This whole list of products excludes the products that will be developed by the Satellite Application Facility, SAFs. The SAFs will have a big range of products newly developed or continuing the current products. If you look only from nowcasting SAF, you will have 11 different products, including the MTG data, several hydrology products, so the precipitation products from hydrology SAF, some land SAF products, and OC SAF products as well. So most of the SAFs will have development of the new products that will be great improvement by using the MTG data. And what do we do to prepare, on one side, EUMETSAT itself, but especially the users to the new generation of the Meteosat data? So first of all, EUMETSAT is fostering the preparation among NMSs by doing the user preparation projects. We have already organized one meeting called MTG User Days or Next Generation User Days. The next one will be on the from the 31st May to 2nd June next year. So we hope to gather many users in order to present the expectation and what's new with the next generation. Not only Meteosat, but also the EUMETSAT Polar system, 2nd generation. Then we organize many technical webinars. You have here the link to the place where you can find the recordings of the webinars, which have covered all of the instruments. So which I didn't have time to talk about all this today, but you have recordings of the webinars where you can hear the details about each instrument. Then a lot of material is included in the science conference. There is a page, EUMETSAT page, where you can find the test data in case you want to play a little bit with or test your systems for ingesting the MTG data. This is the page where you can find the test data, and of course training. We try to include more and more in every training event that we organize or we support. We try to include already more and more proxy data and show what the special features or some situations will look like when looking with MTG data. The training, especially EUMETSAT, we started to focus on MTG and EPSSG applications, and we already had several either short courses or included in other trainings like regional courses. We included already the information about MTG and EPSSG data and products. There will be definitely a range of opportunities for and the staff of NMSs to engage. We plan to have test beds in cooperation with ESSL. We plan to organize test beds, and there is also possibilities of online learning. So there is a lot of material available already at the training page of EUMETSAT. I must here also emphasize the importance of EUMETRAIN project, which is developing training material for the next generation satellite data as well, but also providing short courses or event weeks which include the data and products from MTG. So definitely have a look also on the EUMETRAIN web page and see what's offered from the training that can include MTG. There are some fellowship programs, and recent focus of several fellowship programs was on nowcasting applications in addition to NWP, and some of them include already the proxy data of the new satellites, new missions. So this is something that you can look at, and as I mentioned, EUMETSAT ESSL testbeds will be offered to member states NMSs in partnership with ESSL. The topic of these testbeds will be introduction of next generation satellite products to operational forecasters, and soon you will be getting the invitations to your member states. NMSs will be getting invitations for nominations for the testbeds. And with this, I would like to end and take your questions. I know it's been very fast and very condensed. I do hope that you got some idea what the next generation satellites will look like and what they will offer. So maybe we could do it next time more detailed about one topic, but just as an overview, this is it. Thank you for listening.
Thank you, Nataša. Even if it was only an overview, I think it was very insightful. So if you have questions, please raise your hand and Tomislav will unmute you, or you can write your questions into the chat box. somehow it's very quiet.
Everybody's shocked.
Or you made it very clear.
Okay, I don't see any hands raised.
I mean, I see a lot of clapping emojis, so that's something.
Okay.
So we have one question in the chat box.
Okay.
Is it correct to say that we approach the new forecast for NWP like HRR from NOAA?
Yes, well, yes, I'm definitely sure that we approach the new forecast era for NWP, especially when we think of using the IRS, so infrared sounder data, because if you think of the current data that are assimilated in the NWP, and this is from the polar orbiting satellites, which revisit, let's say, twice a day, each of them one area over, let's say, Central Europe, for example. Now we will have the same, but every 30 minutes. So definitely much more data available, especially of the upper troposphere, of the temperature and humidity in many channels. So this will definitely be an innovation that will help NWP greatly. And there is another, just a minute. Okay, would all this innovation be available on the EUMETSAT website, or they will always be linked to the SAFs? Okay, EUMETSAT website, EUMETSAT is currently preparing a new user portal, and most of the data will be accessible through the user portal as well. Currently, we are also upgrading our EUMETView service, so the viewing service, and some data will be available there as the product, so the visualization of the product, but also the data storing and tailoring service will be available for the new data. So you will be able to download and look at the data from the EUMETSAT webpage directly. But as I showed you in the beginning, there will be broadcast of the data via EUMETCAST and also via EUMETCAST terrestrial, so the direct broadcast. And the SAFs, of course, on their pages will have the data, although some of the SAF products will be included in the EUMETView service as well. So both, also on the EUMETSAT website, but in the SAFs pages. Do you think the change to MTG will be different that we had in early 2000 when changing to MSG? Thank you for the question. Well, and when you think about the imaging service, I think that the change will not be that revolutionary as it was from MFG to MSG. Because when we changed from the first to second generation, we suddenly got the possibility to have this great RGBs. And now we will have a few more RGBs, but the change will not be that revolutionary. What will be better will be, of course, the spatial and temporal resolution, but the content of these new RGBs will not be that revolutionary compared to what we had when we compared the first generation 3 channels to the 12 channels of Severi. So this, in this sense, no. What will be revolutionary, I'm sure, will be the IRS, and also lightning imager, because IRS is something that we currently have only on the similar instrument we have only on polar orbiting satellites, so we don't have it with repeat cycle of 30 minutes. And this could be really crucial for nowcasting, especially severe weather. And the lightning imager, which we don't have over Europe currently from the space, so this is something that will be definitely. But let's see how revolutionary will this be compared to the change from first to second generation. But yeah, I'm still looking forward to the new data. And also a question. Thank you, Branko. Thank you, Branko. Yeah. From Monica, several interesting ways of visualizing from satellites were shown. How does EUMETSAT plan to make the data available for the users as visual? Yes, as I already said, we will have many data and products available through EUMETView. We will also offer some Python scripts or Jupyter notebooks for the visualization of the data as well to the users. We are already working on some of them, and as the new data will appear, we will try to include them as well. So this is something that will definitely be offered to the users. It is hard to say. The user portal will enable the access to the data itself, but the visualization currently is planned through EUMETView. But I'm sure also EUMETRAIN is planning to upgrade their ePort, which enables the visualization of the data combined with NWP fields. So there will be a few ways to access the data. In the real time, of course, if you want to access the data in the real time, you will still have to have your own reception and visualization set up at your premises in the NMS. And okay, any innovation on dust observations with MTG? What we expect in the dust observations is better spatial and temporal resolution, since the channels that see the dust are already available with the current generation Seviri. There will be a new 2.25 micron channel. Maybe there will be some improvement in that sense also for the dust observations, but definitely better spatial and temporal resolution will be crucial also for the dust observations. So yeah. The timeliness of the 4 cameras in Lightning Imager will be the same, or data from this is, I'm sorry, Nuno, but this is the information I cannot answer. If Stefan is maybe one of the participants, I'm not sure, maybe he has this information, but I don't know.
We have Stefan.
No, Stefan Boinski, yeah,
Yeah, he's here.
Maybe he would know.
I will unmute.
Yeah, Stefan, can you answer the question whether the timeliness of the 4 cameras of Lightning Imager will be the same, or the data will come one after the other, or?
The 4 cameras are observing simultaneously at the same time, so they're synchronized and they all have the same frequency of measurement and timeliness of data.
Okay, so they will actually be, because as far as I know, they're like very rapidly observing, so it will be available the same time. Okay. Yes, we will. Well, this is something that we will all investigate once the data starts to flow, because the size and the quantity of data will be immense and really much larger than we have now. So how we will operate and how we will use all this data in real time, it is still to be investigated.
I do not see any more questions.
Okay, so. Me neither. So I hope we answered all the crucial. Any other questions at any point? Please, you can point towards me, to my email, or to training@eumetsat.int. We will try to answer the best we can, or point it to someone that can answer you. So any question that you may have, please don't hesitate to ask.
Thank you, Nataša, for being here and for this very nice presentation. And thank you all participants also for listening.
Change the earth. Okay, you're a bit radical. Thank you all.